Hi guys, I'm recording a short video to explain what I've discovered regarding these posts. I've seen this one a couple of days ago, and it says that you shouldn't use CPU limits when you're configuring Kubernetes. Um, Actually, Nathaniel says that he heard that during a talk at CNCF Tel Aviv, and Sean Levran was saying that you shouldn't use actually CPU limits at all, and instead use just resource requests. And this was a little bit funny for me, because I thought that requests are only used during the scheduling of pods. So this didn't make sense to me, so I had to check. And here's what I learned. So first of all, this is my environment. I'm using a cluster based on 4 machines. All of them are running on top of VirtualBox. So this is A, B, C, and Kube control. And I want to run 2 pods that will compete for resources on A. There's a single virtual CPU there. And let me show you how I'm going to do this. So, first of all, Kube control describe node k8s.a. That will show us that actually the node is running at least a single Calico pod, which belongs to the Kube system namespace, and this pod already requests 250 milli. So actually 1/4 of the CPU power of that node belongs to that specific Calico pod. So we're left with 75% for all of the rest. So here's my demo configuration. So I've created a template file with 2 pods. So the first pod is called 600 pod, so pod 600, and I made sure that it's going to run specifically on K8SA machine, and it's run just a single BusyBox machine. But here's a request part. It requests 600 milli CPUs. And here's the second one, very similar, again configured to run on a machine. This one runs the same BusyBox machine, but this one is asking for 50 milli CPUs. Okay, Kube control apply -f, and here are my pods. Kube control get pods, and here they are already running. Now I have already installed in my Kubernetes resource server, so I can monitor what's going on. So I can run kube control top pods, and it takes some time for the metrics for those pods to accumulate. Oh, here it is. So right now we can see that those 2 pods are actually doing almost nothing. Wait a little bit, same thing. So what I want to do right now is to load those pods. So what I'm going to do is I'm going to exec into them. So kube control exec-it, so we'll get a terminal and make it interactive, into pod 50 first. And then what I want to run there is just a bash, a shell script. And I'm going to do the same thing here. So kube control exec-it pod 600. What did I do? Sorry. Okay. So again, and here's how I'm going to load it. What I'm going to do here is I'm going to paste this simple bash command. And this is actually an empty while loop. So let me run that. And while it is running, I'm going to try to monitor what's going on. So it takes some time for this to accumulate. And here it is. We can see that pod 50 is using more CPU than it did before. And this is going in steps. So after some time, we're going to see that it requires much more. So right now, pod 50 is actually taking almost all the CPU power of that node, even though it was promised only 1 out of 20, so only 50 milli CPUs. So what happens when I run the other pod? Will they share 50-50? So I'm going to paste the same thing here again. And now both pods are competing. That's the interesting part. This is what we wanted to see. So again, it takes some time for the data to be received by the resource server. And here it is. So pod 600 is getting more and more. And again, this is happening in steps. So okay, this is almost the last step. So this is the actually almost the end result in our case. So you can see that pod 600 and pod 50 are getting the amount that were promised and a little more. And as explained, the little more is actually the part of the 250 milli CPUs that were promised to another pod, the networking Calico pod that is not using them right now. So our pods can use it the same. The thing is that the pod 600 was promised 600 and it's getting 600. And pod 50 was promised 50. So those requests are working even after the scheduling part. So having seen this, and this is it stays like that. So it is static right now. So having seen that, I had to go back to documentation and try to see if there are any rumors or any reference to that in the Kubernetes documentation. So I had to look, and I got back to the resource management for pods and containers page that I was looking at. And again, I was seeing that when you specify the resource request for containers, the kube scheduler uses that information, whatever. So they are talking about the scheduling part. Only at the end of that section, you can see this little sentence here, sorry. And that sentence is saying that the kubelet, actually the part that is responsible for running the pods themselves, the kubelet also reserved at least the request amount that the system resources specifically for that container to use. So they're not saying it directly, but if this is the kubelet, then we're talking about runtime, because you're talking to the kubelet in Kubernetes A machine. So we're talking about a runtime, and probably the container manager, container D in my case, is using the cgroups Linux feature in order to make sure that this is happening. It was a surprise for me. Thank you for the post. Again, let me show you the post. So thank you, Nathanielin, for writing about that, and hope this was helpful, guys. Thank you.